Part 5. Polynomials of the form ax squared plus bx plus c. Recall that last section we only factored trinomials that had a leading coefficient of 1, or at the very least, we could have had a common factor removed to obtain a leading coefficient of 1. This section we remove that restriction and factor trinomials that have an integer, positive or negative whole number, as the leading coefficient. The trinomials factored here will all be in the form ax squared plus bx plus or minus c. Okay, as we did last section, let's start by multiplying some binomials to see what type of trinomials we will get. Okay, so example 1, multiplying two binomials with positive terms with FOIL and area. Okay, so if we're going to FOIL these first and then we're going to use the area model, and I did put a negative one on the second one just so you can see kind of how it looks. Okay, we'll get there in a minute. Okay, so this guy here, so 5e times 2e is 10e squared. Okay, 5 times 4 is plus 20e's. Okay, 3 times 2e is plus 6e's, and 3 times 4 is plus 12. Okay, remember the O and the I of FOIL usually combine, and this is no exception. So plus 26e's plus 12. Okay, if we were going to use this as an area formula, okay, so we would have 5e's. Now this is where I maybe should have picked smaller numbers, but yeah, what are you going to do? Okay, so 5e's and 3. 1, 2, 3. Okay, and then we had 2e's. 1, 2e's, and then 4. 1, 2, 3, 4. Okay, so this is an area model. Again, we're not really big on these, but we should at least see them. So, okay, so this is an e, that's an e, so e times e is e squared. Okay, e times another e, e squared. Okay, and we end up with 5 of those. And then e times 1 is just an e, another e, and then another e. Okay, and we have the e squared some more. Okay, we're getting that by this e times this e, okay, gives us this one. So that'd be e squared. Okay, then e times e is e squared. Okay, and then we have more e's. Okay, now we have these 3 e's, this one, and this one, all timesing by these 1s. So we're going to end up with rectangles here. 1, 2, 3, 4. 4. Some more here. That is a terrible rectangle. Sorry about that one. Got away on me a little bit. Okay, and then of course the 1 times the 1, those make 1s. 1, 1, 1, 1, 1, 1. Now these would all be yellow because they're all positive. Okay, but as you can see, there are 10 e squareds. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 e's. Okay, and then over here, there's 6 e's. Okay, so 20 e's and 6 e's, just like the O and the I of FOIL suggested. Okay, and then this last little bit here, that is 12 units, so that is the L. So you can kind of see how they combine, and then that gives you an area format for this multiplication. Okay, so that's the idea. I'm going to erase that so I can do the next one. Okay, remember these are all positive, so yeah. All right, erase, 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 erase. If you ever want to see that again, you can just go back and rewind because it'll still be there. Awesome. Okay, so the next one, so 3 times 4, so that's 12x squared. Okay, 3 times 7, that's plus 21x, minus 16x, and negative 4 times positive 7 is negative 28. Okay, so like I said, we should do the area one for this one too, just so you can see how the positives and the negatives. Okay, so those are rectangles, and then 1, 2, 3, 4, 6, 7. Okay, and then we have 3 rectangles, 1, 2, 3, and then minus 4 squares, 2, 3, 4, and remember those ones being negative, those ones are red. Remember, a negative times a positive is a negative, so anything on those columns will be red as well. Okay, so look, we get this, x times x, those give us the x squareds. Okay, so as you can see, there's 12x squareds. Okay, and then we're going to have these rectangles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. Wow. Okay, now we're going to have these red rectangles over here. And I know they're red because a rectangle and positive x times a negative 1 is going to give a negative rectangle. I won't bother filling these in because I'm drawing them in red. But okay, and that is going to be negative 16 red rectangles. Okay, and then of course negative 4 times positive 7 gives negative 28 of these little tiny squares. Okay, and I'm just going to write negative 28 there because you guys can see the idea. So there's the area equation. Now, the funny thing about polynomial tiles, when you have positives and negatives of the same shape, they cancel each other out. So here are 16 red x's, so that's minus 16. Here there's 21 positive x's, 21 positives and 16 negatives, so that there's going to be 16 cancel off. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, cancels off with another 4 positives, and 1, 2, 3, 4 cancels off with another 4 positives. So as you can see, what ends up happening is that we don't end up with a complete rectangle anymore, which means it's really hard to factor with polynomial tiles. You can make the rectangle again with various additions of positive and negative tiles at the same time, but it just makes it really hard. Okay, either way, the final answer here is 12x squared. Okay, plus 21 minus 16 makes plus 5 x's. And then we end up with minus 28. So there's our answer there. Okay, great. Okay, in the last section, we used our brains and through thought of what factors had to be, or thought of what the factors had to be in order to make it all work. We called that factoring by inspection. We read the equation from left to right to guide us as to what type of factors we might have. We're going to do a similar thing here, and we call this method Big X. Okay, and we call it Big X because there's a 50-50 chance that your work will make a Big X. And you'll see. And again, sometimes it'll work, sometimes it won't. So that's okay. All right, so how this works, or what we're going to do, is underneath the 4, I'm going to write all the factors of 4. So 4m squared, so 4 and 1, 2 and 2. Okay, that's all the factors of 4. Okay, so now I'm going to write all the factors of 6. So 6 and 1, 3 and 2. Remember, this is glorified guess and test, so it doesn't matter what order you put them in. It just matters that you write them down. Okay, now we are looking. See, last time we said, okay, you have to multiply to positive 6 and add to 11. Well, this time there's a little more to it because there's this 4 here. Okay, so it's factors of 4 times factors of 6. Okay, so that works, and then those factors have to add to 11. Okay, so watch how this works. So really, reading it from left to right is helpful. So we say factors that add to positive 11. Okay, we don't even need the positive 11. We'll just say factors that add to 11. Okay, and we'll see what happens. So let's just do the first one. Okay, 4 times 6 is 24. 1 times 1 is 1, and they add to 25. Okay, so that is not what we're after, so we'll erase those. Okay, again, it's just guess and test. So let's try the other one. So 4 times 1 and 1 times 6. 1 times 6 is 6. 4 times 1 is 4. Okay, those add together to make 10. Okay, we want 11, so we're closer, but that's still not it. Okay, so if we look at this one, 4 times 2 and 1 times 3. Okay, 4 times 2, and I'm going to write the 8 right beside the 2 because that's where he came from. 4 times 2 is 8. 1 times 3 is 3. And oh, look, 3 plus 8 is 11. Awesome. See, that works. Now we put in what kind of 11 do we want? Well, we want a positive 11. So what do the numbers 3 and 8 have to be to make positive 11? Well, I need a positive 8 and a positive 3 to get positive 11. Okay, awesome. Now, these signs back up one. So plus 3, plus 2. So now when you make the brackets, remember these are all your letters, 4M, 1M, 2M, and 2M. So we have a 4M and a 1M. Remember, you don't have to write the 1M. You can if you want. Okay, now the 1 multiplies the positive 3. The 1M multiplies the positive 3. Now remember from rainbows or from distributive law, okay, those two multiply each other. So the 4M multiplies whatever's back here. So the 4M multiplies, that's this line here, multiplies the positive 2. Awesome. So the 1M multiplies the positive 3. And there you have your first big X, or first experience with big X. Okay, those are the factors, and it works. If we try that, we get 4M squared, okay, plus 8M, plus 3M, plus 6. The O and the I combine, and you get plus 11M plus 6, which is our question again. So this indeed is our answer. Whew, that was intense. Okay, so let's try that again. Okay, for B. So factors of 6. So 6 and 1, 3 and 2. Okay, it doesn't matter what order you go in, it just, the 6 and the 1, they have to multiply to 6. So we're going to put them in their pairs, 3 and 2, multiply to 6. Okay, so same thing with 10. So 10 and 1 multiplies to 10, and 5 and 2 multiplies to 10. Okay, so again, we're going to read this from left to right. We say factors that do this. So factors that subtract to 7. Don't worry about the negative 7 right now. We'll worry about that in a minute. So we're looking for factors that multiply and subtract to 7. Okay, and we do a little bit of guess and testing. Okay, so let's try this one. 6 times 5, that's 30. 1 times 2 is 2. Well, those subtract to 28. Well, that's not what we want then, is it? Okay, however, if we do this one, 6 times 2 is 12, and 1 times 5 is 5. Hey, those ones do subtract to 7. Okay, now, well, 12 minus 5 is 7, I guess. Okay, now, here's where we put in the signs. What kind of 7 did I want? I wanted a negative 7. So what do the signs on the 5 and the 12 have to be to get negative 7? Well, I need a negative 12 and a positive 5. And these signs just back up to where they came from. Okay, so the 2 is going to be negative and the 5 is going to be positive. Oh, okay, well then we make our brackets. We go 6x and 1x. Okay, the 6x, these lines are like the rainbows of foil. Okay, so the 6x rainbows to the negative 2. 6x multiplies to the negative 2. Okay, and then the negative 1x rainbows or multiplies to the positive 5. So plus 5. Okay, and there you have it. So if we FOIL this back out, 6x times 1x is 6x squared. 6x times minus 2 is minus 12x. Plus 5 times x is plus 5x. And plus 5 times minus 2 is minus 10. Okay, so that's 6x squared minus 7x minus 10. And there you have your question. Now, wow, I just noticed that I actually have an x squared and an m in this one. Oops, that's a funny thing. Anyways, let's just make this an x, then it'll be fine. Okay, sorry about that, my bad, but easy fix. Okay. Whew, wow, sorry. Okay, next one. Okay, so 9 and factors of 9 are 9 and 1, 3 and 3. Factors of 7 are 7 and 1. Okay, so we're looking for factors that multiply and subtract to 18. Okay, so, all right. Oh, well, that's cool because 3 and 7 makes 21. 3 and 1 makes 3. And those subtract to 18. Well, that's cool. Okay, what kind of 18 do we want again? Well, we want a plus 18, right? Positive 18. So what does the sign on the 21 and the 3 have to be to get plus 18? Well, plus 21 and minus 3. So those signs just back up. So plus 7 minus 1, right? Because 3 times plus 7 is plus 21. 3 times minus 1 is minus 3. So that's this line in here. Okay? All right, so that's how that works. Then make the brackets. So we have a 3c and another 3c. 3c, 3c, and then a 7 and a 1. So the first 3c multiplies the plus 7. The second 3c multiplies a minus 1. Okay, and there is our factored answer. Again, we can try that out. 3c times 3c is 9c squared plus 21c minus 3c minus 7. Okay, so that's 9c squared plus 18c minus 7, which is exactly what we ended up with or had in the question, so we know we got it right. Okay. Notice on this one, we did not make a big X. We just made 2 lines. Okay, like I said, it's a 50-50 chance that you will get an X out of this big X factoring. Okay, in the last one, we've got 8 and 1, 4 and 2 are our factors of 8, and the factors of 5 are just 5 and 1. Okay, we read again left to right, so we're looking for factors that add to 14. Don't worry about the negative 14, so factors that add to 14. Okay, so if we have a quick look, 4 times 5 is 20, 2 times 1 is 2, so 20 and 2 makes 22, so that's not it. Okay, oh, but there it is. 2 times 5 is 10, and 4 times 1 is 4. 10 plus 4 is 14. Awesome. Now remember though, it's not 14, it's negative 14. So we put that sign in, negative 14. So what does the 10 and the 4 have to be to get negative 14? Well, they both have to be negative. Okay, well, if those are negative, then they came from the 5 and the 1, so the 5 and the 1 have to be negative as well. So here you get a 4u and a 2u. The 4u, so here's the multiplying. The 4u multiplies a -1. The 2u multiplies by the -5, so -5. So there's our factorings. There's the answer. Okay, and then again we can check. 4u times 2u is 8u squared. Okay, so they get -4u's minus 10u's, and then plus 5. So -4 and -10 makes -14u. So 8u squared minus 14u plus 5. Okay, so there we checked our answer. We know that it's right, and that's how you use big X factoring. Okay, some kids really like that. Some kids really don't. So another method is called factoring by decomposition, and it does suit some students better. Factoring by decomposition is factoring after writing the middle term of a trinomial as a sum of two terms, then determining a common binomial factor from the two pairs of terms formed. Okay, so let's consider these two binomials, 3h plus 4 and 2h plus 1. We can use distributive property to expand this, and this not the same as FOIL. So we're not just going to FOIL these, we're going to do something different. So I'm going to take the 3h and multiply those first. So 3h, multiply those. And after I've done that, then I'm going to take the plus 4 and multiply those two. Okay, and see how I kind of separate it out like that? So 3h and 2h is 6h squared. 3h and 1 is 3h. Okay, and then 4 times 2h is 8h. And 4 times 1 is 4. Okay, so we get, combine our like terms, and I get 6h squared plus 11h plus 4. Okay, in order to, if we factor that trinomial by decomposition, we reverse the above steps. Notice that the coefficient on the h terms, okay, so this is line 1, this is line 2, and that's line 3. So if we look at the h terms in line 2, okay, so that's the 3 and the 8. Well, 3 times 8 is 24. This is equal to the product of the h squared term and the constant term, right? The h squared term is 6, and the constant term is 4. Well, 6 times 4 is also 24. In order to factor 6h squared plus 11h plus 4, we decompose the h term, the 11h, and write it as a sum of two terms whose coefficients have the products of 24. So let's try some and see how this goes. Again, some kids like this better, some kids don't. If you like big X, stick with that. Okay, we're going to go through these examples and then we can go from there. All right, so first things first. 6 times 4 is 24. What we can do is we can say factors of 24. Factors of 24 that. Okay, see that plus sign? Okay, so we're going to say factors of 24 that add to 11. Okay, awesome. So it's kind of like the inspection stuff we did at the first bit. So they're always going to multiply to the number between them, the 6 times 4, and then they're going to add to whatever this one is, so add to 11. So factors of 24 that add to 11. We'll deal with the negative signs in a bit. Okay, so factors of 24. Well, there's lots of factors of 24, but 24 and 1, 12 and 2, 6 and 4, 8 and 3. Okay, 24 and 1 is 25, 12 and 2 is 14, 6 and 4 is 10, 8 and 3 is 11. Oh, look, there it is. So 8 and 3 are our guys. So watch this. So we're going to have an 8m plus 3m to get 11m. That's how that works. So watch this. We go 4m squared. Now, this part does not matter if you put the 8m there or the 3m there. I'm going to put the 8m, but it really doesn't matter. Okay, we can do the other way as well. Okay, 3m plus 8m, and then we are going to go plus 3m plus 6. So basically we write the equation again. We just break that 11m up into 8m and 3m. Okay, that's all we're doing. Now watch what happens. We're going to group these together, and we're going to factor. So 4m squared and 8m. There's a common factor of 4m. Okay, when we do that, okay, so 4m squared divided by 4m is just m. 8 divided by 4 is plus 2. M divided by m is m. Okay, so that's it. Okay, now we do the second bit. Look at this, 3m plus 6. Okay, there's a common factor of plus 3, and we're left with, okay, so 3m divided by 3 is just m, and plus 6 divided by 3 is plus 2. Notice how those are exactly the same. Okay, so we can factor that out. So m plus 2, and then what's left? We have a 4m, and then a plus 3. So that is our final answer. Okay, so we decompose that middle term, that 11m, into 8 and 3. Okay, we group them together, and again, it doesn't matter how you group. Okay, it'll just work out to a different order, not a problem. Okay, we factor each little group, and we're always going to end up with an m plus 2 and an m plus 2, or two factors that are exactly the same. So that becomes one of our factors, and then the 4m and the 3 becomes our other ones. Okay, so let's try B, just to kind of cement these ideas. Okay, so 6 and 10, that's negative 60. 6 and negative 10. So I'm looking for factors of negative 60. So factors of negative 60 that add to negative 7. Okay, so what would factors of 60 be? Okay, so if we look at the factors of 60, okay, and let's not worry about the negative 60 for a bit. Let's just look at factors of 60. So factors of 60 are like 6 and 10, 4 and 15, 12 and 5, of course 60 and 1. Okay, now we know that one of these is going to be negative. Okay, one of them has to be. So we either get negative 6 or negative 10. Okay, negative 4 and positive 15, or positive 4 and negative 15. So that's how we get the negative 60. So instead of saying add to negative 7, if we just say subtract to 7, then we can use these numbers as they are. Okay, so which of these subtract to 7? So if we go 10 minus 6, we get 4. That's not going to work. Okay, if we go 15 minus 4, okay, we get 11. Okay, if we go 12 minus 5, hey, there's the 7. So that's what we want. Now, to get the negative 7, okay, we have to have a negative 12 and a positive 5. So that's the set or the combination that we want. Okay, so the 12 and the 5, those are going to be, oh, I did it again. So 6x squared, and then let's make that an x. Sorry, haha, very funny. Okay, so 6x squared and 7x. There we go, good enough. Okay, so that's going to be a negative 12x and a 5x. Now, again, it doesn't matter how we group these things. And maybe what I'll do is I'll do them both ways just so you can see it once. Okay, so you get a 6x squared. Now let's put the minus 12x first, plus 5x minus 10. Okay, so if we do it like that, okay, and then so we group them off like this. Okay, so 6x squared minus 12x. Okay, well, there's a common factor of 6x there. Okay, so if we put the 6x, okay, so 6x squared divided by 6x is x, and negative 12 divided by 6 is negative 2, x divided by x is nothing. So we just have x plus 2. Okay, now plus 5x minus 10, there's a common factor of plus 5. Okay, 5 divided by 5 is just 1, so we get 1x. Okay, and then negative 10 divided by 5 is minus 2. Oh look, x minus 2, x minus 2. So that's the first bit, and then we end up with the 6x and the plus 5 as our other term. So 6x plus 5 and x minus 2. Okay, now tell you what, let's write in orange just for a second. What if I got them backwards? What if I had the 6x squared go with the 5x and the minus 12x go with the minus 10? Okay, so we group them that way instead. What would happen? Okay, so the first one, okay, the only common factor there is an x. Okay, so we get 6x plus 5. Okay, and then look, minus 12 and minus 10. The only common factor there is a minus 2. Okay, negative 2 or negative 12x divided by negative 2 is 6x, and negative 10 divided by negative 2 is plus 5. See, look, the 6x plus 5, okay, so that's the one that's in both terms, and then the one that's left over, so the x and the minus 2 go together. So it really didn't matter where you put the 12x and the 5x, okay? You just continue factoring, and it works out to the same answer regardless. Okay, it's pretty cool. All right, blue pen, there we go. All right, let's try the next one. Okay, so 9 times minus 7 is negative 63. Okay, and again, instead of saying negative 63, we're just going to say factors of 63, and then we're going to use that. So factors of 63 that subtract to 18. Okay, so 63 and 1. Okay, we have 21 and 3. We have 9 and 7. Okay, and I'm looking, again, let's just follow that through. One of those signs has to be negative to get to a negative 63. Okay, so, but if we have to say that, then we have to say, okay, well, it adds, or that makes it more confusing. So if we just say factors of 63 that subtract, so whatever that sign is, add or subtract to whatever that number is. Okay, so we're going to say factors of negative 63 or factors of 63 that subtract to 18. Okay, well, oh, there it is, 21 and 3. So that subtracts to 18. But look, I need a positive 18. Okay, so what do the signs on the 21 and the 3 have to be to get positive 18? Well, I need a plus 21 and a minus 3. Okay, so we get a 9c squared plus 21c's minus 3c's, okay, minus 7. Okay, so that's, again, the order of these two doesn't matter. That's why I showed you up here the orange. As long as you just put those there, then they'll factor out just fine. Okay, so then we take those two, so group those two and those two together and factor. Okay, the lowest common or the greatest common factor between each one. So between 9 and 21, the greatest common factor is 3. Okay, this one has a c squared, that has a c, so it's 3c. Okay, that's the greatest common factor. So 9c squared divided by 3c is 3c. 21c divided by 3c is just plus 7. Okay, negative 3c and negative 7, the only common factor there is negative 1. So we'll actually write the negative 1 this time. And then negative 3c divided by negative 1 is positive 3c. And negative 7 divided by negative 1 is plus 7. See how the 3c's plus 7, they're the same now? So that's one of our factors, 3c plus 7. And the other one is the 3c minus 1. And there you have it. There it's factored now. Perfect. Okay, let's try it one last time. Okay, so 8 and 5. So those are factors of 40. So we have factors of 40 that, oh look, we're going to read this way, factors of 40 that add to negative 14. Okay, So let's see, factors of 40. 40 is 8 and 5, 20 and 2, 40 and 1, and 10 and 4. So we want them to add to 14. We know that both of these signs are going to be the same. They could both be positive or both be negative. Okay, so look, positive 8 and positive 5 make positive 40, but they add to 13, not 14. Okay, so that's not it. Okay, if you look at this, 10 and 4, they add to 14. Now, what kind of 14? It's a negative 14. So what do the signs on the 10 and the 4 have to be? Only both have to be negative. Right? Negative 10 plus negative 4 is negative 14. So look, we get an 8u squared. Okay? So we have a minus 10u minus 4u plus 5. Okay? So that's how that one works. Okay? So group those together like so. Okay, 8u squared minus 10u, so the common factor there is a 2. Okay, 2u, I guess. Okay, so 8u squared divided by 2u is 4u, and negative 10 divided by 2 is negative 5. U divided by u, of course, is just nothing. Now look, is there anything we can factor out? Minus 4n plus 5. There's no negatives, there's no numbers. The only thing I can factor out of there is a plus 1. Okay, and then you end up, actually, pardon me. No, we don't want to factor out the plus 1, right? Because we want a 4u, so we're going to factor out a negative 1, and you get plus 4u minus 5. Now look, the 4u minus 5's match. And then the 2u and the minus 1 go together. So 2u minus 1 and 4u minus 5. And there you have it. Now, just in case you didn't notice, the questions from example 3 are the same as from example 2, including my little mix-up with the x's and the m's up here and b. Oops, sorry about that. Okay, the answers are the same, regardless of which method you use. Both tools, big X and decomposition, are acceptable, and some students like different methods. The main idea here is that it doesn't matter how you factor the trinomials, it only matters that you do factor the trinomials. You will not receive extra marks or lose marks because you do it one way as opposed to the other. And lucky for you, you never actually have to do it twice. You just pick one method and do it. Okay, so for now, I'm going to encourage you to try both methods, and then after you've tried them for a bit, decide which one you like best. Okay, so we have one more example that are going to combine the ideas of this lesson and the last one. Okay, example 3. Factoring a trinomial with a common factor. Now, you will notice 24, 20, 24. Okay, we can jump right to big X or decomposition right from here. But the idea is, let's look if there's a common factor, because if we can get away with this being a factoring by inspection, or at the very least a smaller big X or smaller decomposition, then it'll be easier for us. So if you look, 24, 20, and 24 all have a common factor of 4. So this would be 6h squared. Negative 20h divided by 4 is minus 5h. And then negative 24 divided by 4 is minus 6. Okay, so even though we didn't get rid of the big X, we did get rid of the 24. So we have much smaller numbers to work with now, because before it would have been, at least in decomposition, 24 times 24. Like, that's huge numbers. So anyways, as it stands now, that 4 just pops out. Okay, you know what? I'm going to do this twice. You don't have to. You just pick a way. But I'm going to show you each way again so you can choose which way you want to do. Okay, so 6, the factors of 6 are 6 and 1 and 3 and 2. Okay, so it's 6 and 1, 3 and 2. You read it from left to right, so factors that subtract to 5. So I'm looking for numbers that multiply and subtract to 5. Okay, if we do that, 3 times 3 is 9, 2 times 2 is 4, and they subtract to 5. Okay, what kind of 5 do I want? I want a negative 5. So what do the 9 and the 4 have to be to get negative 5? Well, we have to have a plus 9, minus 9, and a plus 4. Okay, where do those signs come from? They come from the second numbers, so the 3 and the 2 signs just back up. So then you end up with, okay, the 4 is still there, so then you get a 3H and a 2H, right? These are the H's. Okay, so the 3H multiplies the negative 3, so 3H rainbows or multiplies the negative 3. The 2H multiplies the positive 2, and there you have your answer. Okay, awesome. So we can do it that way. And you know what? I'm going to make this line over here, just so I have a little more room. Okay, so again, you factor out that 4. 6H squared minus 5H minus 6. Okay, so now then you multiply the two end terms, the 6 and the 6. So that's factors of negative 36. So we need factors of 36, and again, reading left to right, factors of 36 that subtract to 5. Okay? Now, okay, factors of 36 that subtract to 5. Don't worry about the negative yet. We'll get that in a second. Okay? So let's see. Factors of 36. Well, that's going to be 9 and 4, 18 and 2, 36 and 1. Okay, well, anyways, the 9 and the 4, they subtract to 5. So what kind of 5? It's a negative 5 is what we want. So if it's a negative 5, what does the 9 and the 4 have to be? The 9 has to be negative, the 4 has to be positive. So we're going to decompose the 5H into negative 9 and plus 4. So watch this. So the 4 is still there. 6H squared, okay, minus 9H plus 4H minus 6. Okay, and now that we've decomposed, we group those like so. So we get a 4. Okay, that's still there from the beginning. Now, 6H squared and 9H, there's a common factor of 3H. Okay, so 3H, 6H squared divided by 3H is 2H. Negative 9 divided by 3 is negative 3. H divided by H is nothing. Okay, and then 4H and then minus 6. Okay, so there's a common factor there of plus 2. Okay, 4H divided by 2 is 2H. Negative 6 divided by 2 is minus 3. Okay, oh look, the 2H minus 3, 2H minus 3. So the 3H goes with the plus 2. So we get a 3H plus 2 and a 2H minus 3. And you get exactly the same as you did with big X. So again, you don't have to do both methods, but I did want to show you that both methods work for either way. So it's up to you. You guys choose. Okay? Now, so we're done this section, so I'd like you to practice this material by completing the following questions. This is section 3.6 in your textbook, starting on page 177. So it seems like there's quite a few questions, but again, you need to practice this. Okay? If you have any questions, please ask your teacher. Make sure you show them your work once you finish it so they can release you to the next section. Thanks, guys. Good luck. Watch the video again if you need to. Either way, we'll see you in next section.